Welcome to this new C# lesson. In today's lesson, we will learn about C# casting and type conversion. We learned from the previous lessons that C# is a strongly typed language, which means every variable and object must be declared with a specific type. A variable declared with a specific type cannot be used to store values of another type unless that type is convertible to the variable's type. We also learned that we have two types of data type in C#. We have primitive data type, also known as predefined data type or built-in data type. And the second type is the non-primitive data type, which is the user-defined data type. In the primitive data type, we have the following. So we have byte. These are the data types we have. We have byte, short, integer, float, double, long, character, boolean, datetime, string, object, and others. In the non-primitive data type, which is the user-defined data type, we have class, structure, enumeration, interface, delegate, and array. Now let's talk about casting or converting between these types. In C# we have two types of conversion. The first conversion is called implicit conversion. The second conversion is called explicit conversion. The implicit conversion is done to us by the compiler, and we do not have to worry about it. On the other hand, the explicit conversion is done explicitly by the user using predefined functions. Okay, now let's go to a Visual Studio and work with some examples. I have started a project, named it numeric conversion. I'm gonna double click the button to create click event. And here we're gonna talk about the following. So we're gonna talk about built-in numeric conversion. We will also talk about implicit conversion, and finally we will give examples of widening conversion. Okay. First, let's define what is casting or converting in C#. Casting is the action of changing an entity of one data type into another. The basic rule is that assigning value of one type of a variable to another type is not a valid operation, except for implicit casts, as we will demonstrate. The built-in numeric types can be assigned to each other if narrow type is being assigned to a wider type. This is also called a safe type conversion, because the compiler does the conversion for us and no data will be lost. What is an example of that? If I take int, and I'm gonna call it int num equals, let's just give it, for instance, 2017. Then I'm gonna say long num equals, and I'm gonna say int num. What's happening here, I'm taking this int num, the variable, which have the 2017 value in it, and I'm dumping it into a long. And as you can see, this was done without any problem, because as you can see in this picture, the contents of a narrower type integer can be stored into a wider type long. Alright, as long as we're not losing any data, the compiler does not complain. We can also do this. For example, we can say uh, decimal num. Okay, and we're gonna say int num. And as you can see, it did not complain. Why? Because again, decimal is way larger than the integer, and there is no loss of data, because it doesn't matter how big your integer is, it can always fit inside a decimal. Now let's do the other way around. We're gonna go from a wider type into a narrower type. So we're gonna call this examples of conversion. So let's say we have long, I'm gonna just call it L equals 10. Okay, and I'm gonna say int I equals L. Here it's complaining. The compiler is complaining. Let's see. It says cannot implicitly convert long into an integer. An explicit conversion exists. Are you missing a cast? So it's telling us I cannot put this 10 inside an integer. And you might ask yourself, well, 10 can fit inside an integer because the integer can take more than 2 billion. Well, the compiler does not care about that. The compiler is worried that you may want to store more than the values that can fit inside the integer. And there it's telling you that I cannot take this long and put it inside the integer unless you want to do it yourself. So how are we going to do it ourselves? Basically, we are going to tell the compiler, yes, we know there is a risk of information loss, but we still want to go ahead and do it. So how do we do that? We're going to come here and we're going to say the following. We're going to say int, and the compiler is not going to complain again. Okay, so basically what I'm saying here, I'm saying take this long, turn it to an integer, and dump it inside the I variable. That's what I'm saying here. Okay, let's take another example. I'm gonna say decimal. Let's call it D, for instance. Okay, 19.95, and of course I'm gonna need the suffix, and here I'm gonna say int, or since I already declared it, I'm just gonna use the I equals D, and it's gonna complain. It says here it cannot implicitly convert type decimal to an integer. We need an explicit conversion. This is because the integer is only 32-bit, while the decimal is 128-bit. So the decimal is way too large for the integer. And in addition to that, the integer cannot have a decimal point. And therefore, if we want to convert a decimal to an integer, we are going to lose data. So let's see that. First, let's convert it. And to convert, I'm gonna do int like this. And by the way, this is how we convert. So if I want to convert this decimal to a double, I'm just gonna put it between parentheses and before the variable and say double. And if I want to convert it to long, I just say long. If I want to convert it to byte, I just say byte like that, and so on. Okay, but I'm gonna convert it to an integer. So I'm gonna display the value in message box. Okay, I'm gonna say I that to string, and the reason I'm displaying the value of I, because we took D, this one here, the 1995, converted it to an integer and dumped it into the I variable. Let's see what's going to happen. I'm going to press Ctrl S to save, and I'm going to run. So bring this here, click, and we have 19. As you can see, we lost data. We lost the decimal point, 95. We only have 19 because integer can only show or hold whole numbers. It cannot hold decimal points. So here we lost data. There are other situations where we lose precision. Okay, and that will be covered in the next lesson. And with this, we come to the end of this lesson. I'd like to thank you for watching. Have a good day.